Hello everyone, this is Teacher Alan, once again representing to online. I'm always here to take you through biology and chemistry, theory and practical. For today, I'm here to take you through some bit of biology, paper 2, an item from physiology, and specifically from food tests. Today's practical is going to be brief because we've been doing a number of them, and I know we are we have enough concept about these practicals. We have enough information we can use to actually do these practicals. So the item is already in the description of the video you are watching. Or you go to our website for the video, for the item, or the WhatsApp group, it is already uploaded there. But the item goes, James has two children, Paul and John. Paul always feels fatigued, has a dry skin, wasted muscles, with swollen feet and hands, and loses hair always. John has a very poor wound healing ability, bleeding gums with severe joint pain. On presenting them to hospital, the doctor gave him two fluids, fluid A and fluid B, with supplements required with, sup- with supplements required by the two boys. Unfortunately, the fluids were packed without labeling them. Which one belongs to Paul or John? He has presented samples of the fluids A and B to you. He would like you to carry out investigations and find out which fluid belongs to who. You are provided with fluid A and B. We have the fluids A and B. We have B here and A is here. And all laboratory reagents for food tests, they are here. We have DCPIP, we have copper sulfate, we have sodium hydroxide, we have Benedict's solution, we have iodine solution, and other apparatus. For example, here we have the test tubes on the rack. Task: as a biology learner, carry out investigations to help James solve his problem as you're seeing that item. So the item, analyze it, it is an item from food testing. James had two children. He has Paul and John. Each of these ones is presenting or is showing some symptoms of deficiency of a certain nutrient. When we go through the symptoms displayed by Paul, there is fatigue, dry skin, wasted muscles, swollen feet and hands with loss of air. So Paul loses hair, has wasted muscles, there is fatigue, ever tired, dry skin, the hands and the legs are swollen. Last time we said swelling of this is edema. And John is presenting these symptoms, which are very poor wound healing, bleeding gums with severe joint pain. and the setter of the item wants us to help James make the best choice because he was given two food solutions, A and B. The doctor forgot to label them. And there are reasons to why he's not going back, why James is not going back to the doctor. He has approached you for help. So you are going to do the needful to help James. We are going to call out food tests on these ones, but in line with solving a problem that is stated in the scenario. Basing on the symptoms Paul is displaying, they are all in line with the deficiency of proteins. And this protein deficiency causes a medical condition we call kwashiorkor. And basing on the symptoms displayed by John, vitamin B or ascorbic acid deficiency. And we remember that the deficiency of ascorbic acid in the body causes a medical condition we call CKV, which is characterized by the other symptoms: bleeding, gums, very weak teeth that are loosely attached in the gum. There is poor wound healing, and so on, joint pain or fatigue. All those ones are some of the symptoms of deficiency of ascorbic acid. So in short, the aim for this investigation is going to be an experiment to find out which of the solutions A or B contain proteins or vitamin C so as to be given to Paul and John. I think the one that has proteins is to be given to Paul. The one that has vitamin C is to be given to John, respectively. Basing on the scenario, to me, I would go to this direction. You can also think of your direction, but finding out which of the food solutions, A or B, contains which nutrient that is required by Paul or John. So my hypothesis will still be in line with these food nutrients. Hypothesis: Paul is deficient of proteins, hence needs a solution with the proteins as John needs a solution with vitamin C. So alternatively, you can say solutions A or B contains proteins and vitamin C respectively. So we remember we have the variables. We said we make table with variables and then the description of the variables. So we have the controlled variables, what we shall keep constant throughout the investigation. For now, I'll make sure I use the same volume of solutions and be in all experiments. I'll make sure I use reagents. The reagent that will be used on solution A will also be used on solution B. I'll make sure I will make sure I will not vary the temperatures for the reactions. I'll make sure I boil none of them. So for the independent variables, what will I be changing so that I can get results are the food solutions A or B. In one set, I will be using A, as in the other, I will be using B. And then the dependent, what will I be looking for? Is the color changes for the reagents. I'll be looking at the color changes. Which color of the reagent do we obtain when we add it to this solution or the other will be my dependent variable. We know these ones now. We know that when we study the A, we study the hypothesis next. The next step is already stating the requirements. I know we've been doing a number of these investigations, and for us, we always, as Muto, we always separated the apparatus from the materials. And we know why. The materials we need the food solutions A and B. Which reagents do we need to test for proteins? Because we are going to test for these two, ascorbic acid and proteins, because they are the ones that are in line with the scenario. So which food solutions do we need? Which reagents? We need DCP, IP, DCP-IP solution, or dichlorophenoindophenol solution. We need, we are going to use copper 2 sulfate solution. We need sodium hydroxide solution. And I think these are the only reagents we need. For the apparatus, we shall need, because we shall carry out a protein test on A and B. So those are two test tubes. And we shall carry out a test for vitamin C on A and B. So far, those are 4 test tubes. So we shall need 4 test tubes. Remember when testing for vitamin C, we put the food solution in a test tube. We put the reagent in a test tube. It is the food solution that we add in drop-wise form. We add the food solution drop-wise until in excess. So we shall need 2 droppers because since we have 2 food solutions, A and B. So we shall need 2 droppers. For what? For adding the food solution to the DCP-IP in a test tube for the 2A and B. So what we shall use in A will not be the one that we shall be using in B. What else do we need? I think basically they will be the ones for this food test. The next thing is to write the procedures. For the procedures, what do we do? We transfer known amounts of food solutions. So what we shall do, we shall label the test tubes. We shall give test tubes names so that carrying out the procedures becomes simpler. 4 test tubes were labeled. Let's give them numbers. 1, 2 were labeled as 1, 2, 3, and 4. Then we start to test. We are going to start with protein test on A. To 1 cubic centimeter of food solution A in a test tube 1 was added. Now we are testing for proteins. Was added 1 cubic centimeter of sodium hydroxide. Remember, this is the solution. and the results were recorded. I think we can see this. Again, to 1 cubic centimeter of solution B in test tube 2 was added we add equal amounts, 1 cubic centimeter of sodium hydroxide solution, because this is incomplete, was added 1 cubic centimeter of solution, sodium hydroxide solution, followed by 2 drops of copper 2 sulfate solution, and the results were recorded. Now, to 1 cubic centimeter of solution B in a test tube, we are now in the second solution, second test tube. This time using solution B. This in test tube 1 we used solution A. So you can take your own direction. What is simpler for you? 1 cubic centimeter of solution B in a test tube 2 was added in that of sodium hydroxide solution, followed by 2 drops of copper 2 sulfate solution. And then we shall also do the same tests on A and B for reducing sugars. I mean for vitamin C. So for vitamin C, we always say to 1 cubic centimeter of DCPIP solution in a test tube was added drop-wise, drops of solution, of any solution. This time it is solution A. This is test tube. In test tube 3 was added drops of solution A until in excess. And you can again write about test tube 4, but for me, I'm going to just say the procedure above was repeated. This procedure here was repeated in test tube 4 using solution B. So we have test tube 1 where we added we tested for proteins on solution A. Test tube 2, where we tested for proteins, because these are the reagents for the Butylates test. The reagents are sodium hydroxide and copper sulfate. They are the reagents for Butylates test, for protein test. And in test tube 3, we are testing for vitamin C in solution A. Remember, for testing vitamin C, to 1 cubic centimeter of DCPIP in a test tube, we always add drop-wise any food solution until in excess. So what are the results? So the results obtained were then recorded. Members, what is key food test is you knowing the really procedures and the reagent with the expected color changes. This practical is an open practical now. The other may be about one food nutrient, and they want you to compare the amount in each of the solutions provided. They may be containing the same food nutrient when the question is requiring you to test for the amount of each food solution. So the next step is you giving the results. And the results for food tests, we know them very well. We give the test, and which test now are in test tubes. We give the observation, and we also give a conclusion or deduction. A conclusion or deduction. So we have test tube 1. Please give the description of test tube 1. What 1 cubic centimeter of, like the way you stated it in the procedures. We are going to carry out the tests in test tube 1. If this is our test tube 1, we said that 1 cubic centimeter, if this is my 1 cubic centimeter of A, I'm going to add 1 cubic centimeter of sodium hydroxide, equal amount of sodium hydroxide. So I'll add 1 cubic centimeter of sodium hydroxide. It's what I'm adding, equal volumes. To the same amount, you're telling us to add 2 drops of copper 2 sulfate. Here's my copper 2 sulfate. So I'm adding 2 drops of copper 2 sulfate. So we are checking whether this substance contains proteins. If the solution turns to purple, violet, if the solution turns to purple or violet, it is an indication that that solution it contains proteins. Like for this one, which color is that? When you look at it, I think this is purple. I think in test tube 1, the solution is turning to purple. So this means you come and write your observation. What was the nature of the solution? Is it as colorless as the solution? Because we have how many tests in this procedure? We have putting solution A in a test tube. What was the nature of solution A? It was a turbid solution. So you come and say it is turbid solution. Turned, because you did the investigation. You are reporting what you did. So when do we write turbid? We write turbid when the solution is actually more thick than water, irrespective of the color. So long as the thickness of or the viscosity of the solution is more than that of water. So we write turbid. So it was a turbid solution. When we added the reagent, because the second test in the procedure is adding the reagents. We count what it turns to when we add all the reagents. And the observation written in the Buletis test is what it turns to when we add the final reagent, which is copper to sulfate. So it turned into a purple solution. Members, please and please and please state the nature. The nature will be scored if you put, state the color the color will be scored if you state the nature of the product. The nature is a solution. It may either be a precipitate or a solution. So even here, as you're stating the color that it is purple, don't forget to state the nature of the product. The product is a solution. So it is a turbid solution turns to a purple solution. When that happens, our conclusion will always be proteins present. But cases where proteins are absent, we always get the turbid solution, or the color, the nature and the color of the solution will always turn to a blue solution. Let's try with B. Same procedures. So this is our solution B. So we have added 1 cubic centimeter of solution B, and then we are adding 1 cubic centimeter equal volume of sodium hydroxide, and then we are going to follow that with 2 drops, the 2 drops of copper to sulfate, 1, 2. And I think there is a difference between these 2 solutions. It is evident it is purple, and this one, it is a blue solution. I think we can see. So previously, the solution was more turbid than water. So for test tube 2, the observation we had is a turbid solution turned to a blue solution. It is a solution because it is clear. Let's try with test tube 3. They are saying we are getting DCPIP into a test tube. We have 1 cubic centimeter of DCPIP in a test tube. So which color is this solution? You come in your observation table, you have to report the color of the solution as you placed it in the test tube. So it is a blue solution turned to what? Let's try to add excess of solution A. So we get a dropper, dropwise. So we add dropwise. So there is an extent we shall reach and have no hope of the solution to change. So we are adding drops of A. We can still add we are adding the solution. We've added a lot of it until in excess. The blue solution is remaining a blue solution. You can add until when you feel I've really added excess. The solution is not turning. Much as you've added a number of drops, the solution is remaining a blue solution. So in our observation, we shall come and say, so remember this observation is an indication that the proteins are absent. So the blue solution in test tube 3 did not turn, but remained a blue solution. Alternatively, you may say a blue solution. We are recording the color of what we placed in the test tube. It was the dissipate which was blue. So the blue color of the blue solution remained a blue solution, or the blue color of the solution remained or persisted. This is an indication that the vitamin C is absent. So in test tube 1, we are carrying out a protein test on A. Here we are carrying out a protein test on B. Here we are carrying out a vitamin C test on A. And we are finding that there is no vitamin C in A, but we have proteins in A. Don't forget to review the nature of the product and the solution and the extract that we are given. Having finished A, let's try test tube 3, where they said, test tube 4, we are repeating these procedures in test tube 3 of putting 1 cubic centimeter of this CPIP, and then we add solution B dropwise until in excess. So this is our solution B. We are going to add solution B dropwise until in excess. There are some experiments where we shall find that we need to compare the amount of vitamin C in each solution. For there we shall be counting the number of drops and we shall be recording. And it is evident that vitamin B contains vitamin C. Solution B contains vitamin C. Where the solution of this, the blue color of the dissipate changes to colorless, it is an indication that this CPIP is present. I mean, vitamin C is present in that solution. So the blue for test tube 4, the blue solution turns to a colorless solution on excess addition of B. And this is an indication that there is vitamin C present. So this is our table of results, and these are our results. Not only results, but also our conclusions, our corresponding conclusions. The next thing is to give an explanation. But in this case, we just need to recommend. So, Paul, being deficient of proteins, needs a solution that has proteins, that has more of the proteins in it than any other nutrients, and that is solution A. So Paul needed solution A. Why? Because it contains proteins, and so it will supplement the diet of Paul to get rid of the symptoms of the kwashiorkor. And then John, being deficient of ascorbic acid or vitamin C, John, being displaying symptoms of scurvy, needs a supplement or a food solution that contains vitamin C. And we are finding that John needed solution B. And therefore, from the tests above, John needed solution B as solution B was for Paul. Why? Because of the nutrients that are present. I'm taught online, and we said, if you really like what we do, you comment, like what we do, share with friends. Don't forget to like if you really like what we do. I'm Teacher Alan, representing Online.